Here's course Introduction to Algorithms. The topic Time Complexity, Measure and Algorithm. How to measure algorithm complexity. First of all, what counts when we are performing the time complexity measurement of an algorithm? And to do that, we need to understand what asymptotic complexity stands for. But remember, we can't measure the time complexity of a program, just an algorithm. And algorithms always end at some point. Asymptotic complexity. If we compare the absolute time of execution of two algorithms, we would be comparing subjective values. Since they are specific to a particular hardware and context. For example, even if we run both algorithms on the same computer, each program would have to run without sharing CPU with other programs or operating system service. And even the order in which we run the programs can affect their result due to the thermal characteristics of the CPU or the mirror acceleration of their ambient temperature. So we need to compare their running time mathematically here where the term asymptotic complexity comes in. Considering that the time complexity of an algorithm summarizes how the execution time of algorithm grows with the input size. This growth is calculated based on how many steps, for example, how many times it enters in a for loop. An algorithm need to do in order to solve a problem given n number of elements to be counted. But we cannot consider just one value of n to measure a complexity of an algorithm. Because as we know, a program can be very efficient for big values, but not the best choice for small values and the other way around. Worst and best case. Since it's almost impossible to consider all cases, we choose the worst and best scenario of an input to calculate the complexity of certain algorithm. Worst case runtime means that you are feeding the worst possible input of that size into your algorithm. Best case runtime means that you are feeding the best possible input into your algorithm, which is the fastest scenario. Here's a big O notation. In short way, the big O notation is a way to classify how scalable our algorithm is. This helps us determine how our algorithm will behave in the worst case, or how long it will take to complete based on its input values. To get the final equation, there are some rules we need to follow. First is to drop constant values, such as a variable declaration and other expressions that just happen once while your algorithm is running regardless of input size. And non-dominant terms, since this one has minimal effect on the growth curve of time complexity when the input size are very large. So being the horizontal line, the growth of time complexity, and the vertical line, the input size. Note that the equations that have exponential degree are the worst ones, because as the number of input size grow, the time complexity is more than duplicated, and constants would have almost no effect on the growth of this curve. So here's the example. Given a sorted, so in other words, least to greatest array of size n. So we should find the index of a value m. If it doesn't exist, result -1. So one way would be to iterate along the list, checking each and every element to see if it's the desired value, and this is called the linear search. Another way, commonly called the binary search, leverages the fact that the array is sorted. If one starts from the middle, they can easily cut the problem to half its size, as the desired value is on one side or the other, and figuring out which side it's on relies and on a simple comparison. Clearly, both will work, both algorithms will eventually find the answer, but you can also make the observation that the binary search is better. It's not because it's more sophisticated, but rather that it's faster. So if you had an 1024 element array, you can expect the following number of iterations for each algorithm. So is binary search 50 times faster than linear search? Well, not exactly. First of all, binary search requires more time per iteration, as it does at least one addition comparison. Secondly, binary search is less efficient over the cache. So here we have a column like linear search and binary search, and rows, um, best case, average case, worst case. For best case of linear search is one iteration once in 1024. Best case of in binary search, one iteration once in 1024. So here's the same, yeah? Average case in linear search, 512 iterations. And average case for binary search is 9 iterations. Worst case for linear search is 1024 iterations once in 1024. But in binary search, worst case is 10 iterations once in 2. So linear search only requires switching out the cache every few 8 or so iterations. Binary search needs to switch it out almost every iteration. But mostly importantly, binary search use an entirely different approach from linear search, and it grows differently. If you double the size of your input, linear search will take twice as many iterations on average and in the worst case. Binary search, on the other hand, will take one more iteration. Thank you.